All right, now, what I want to do is I want to make a video about the quizzes that we're having. Even though we already corrected the first quiz, I want to demonstrate the equation of the first quiz. Now, what kind of reaction is this? Lead 2 nitrate plus sodium iodide. It's actually quite straightforward. It's a salt plus a salt. What kind of reaction is it? Come on, guys, you can do this. What class of reactions is it? Maunus? Double replacement. Very good. Maunus? No? Really? Interesting. You guys didn't know that? Usaba? Yeah, interesting. Very interesting. Okay, so what are the reactants? The symbols for the reactants. What do I put here? Plus what? NaI. Sorry. Yields what? Anybody? NaNO3. Plus, let me see if this is filming. Let's see if it's on the... Yeah, we got some room. Okay, NaNO3 plus what? Plus what? PbI2. Good. And quite simply, this was, I think, one of the simpler problems to do. It's this and this. Now, let me make sure that's on the... Okay, let me fix this a little bit. Okay, now, what I want to know is this. What is the driving force of this reaction? What is the driving force of this reaction? Anybody? What makes it go? What makes it go? Well, there are two things that can make a reaction go, such as this. Two things. One is the formation of an insoluble solid, a precipitate, will drive the reaction forward. Yes? And this is a precipitate. That's a precipitate. It's a solid. Okay? This is still aqueous. That means it's a water solution. Both of these are aqueous. Both of them are water solutions. Yes? As a matter of fact, the nitrate and the sodium are what we call, do you remember, spectator ions? Remember that? And actually the net ionic reaction, where what are the actual chemicals involved in the chemical reaction? It's going to be lead plus 2 plus iodine, right? That's what's involved. I'm going to balance it like that. Yes? Okay, now, if you watch carefully, you're going to be able to see this reaction. Here I have lead 2 nitrate. It's a little cloudy. There's some crystals on the bottom. But this is lead 2 nitrate. This is sodium iodide. Neither one you really want to take ingest. You want to wear goggles when you do this. Okay? These are actually not good goggles. These are more like for physics. They're not splash proof. Let me show you a better pair of goggles. Hold on. These are a little better. They cover the eyes a little bit better, but they're still not great. You know why? Because they're not completely splash proof. Let me show you. You see these little holes here? See these holes? Liquid and things can get in there. So these aren't considered splash proof. It's important for your goggles. Anybody go snorkeling or anything like that? Yeah? What happens to your goggles when you go under the water because they have to be waterproof? What happens to them? They cloud up, right? So you need air in the goggles, right? Well, actually, good chemical goggles are ones with a valve in them. You have like 3 or 4 valves, like 2 on each side. And the valves help your eyes, help get air in there. Okay? So here I have, these are great for, you know what these are good for? Construction. Or dust, or doing something. But they're not great goggles. Okay? So here I have lead 2 nitrate here. Is it coming on the screen? Okay. Is it right here? Is it right here? Yeah. See, I'm going to put the lead 2 nitrate into the sodium iodide. Okay? See that? That material, that orange-yellow material is the lead 2 iodide. You see how that formed? Now, before this video is over, I wanted to start with this. Before this video is over, you're going to see the material settling. It's very fine. It's like sand almost. It's very fine. And it will slowly settle. I'll put that over here and I will do the next problem. Okay? Pretty cool, huh? It's a cool experiment, yeah? Okay. All right, let's look at this next one. Here I have a gas experiment. This is gas. This is gas. And this is gas. Okay? Now what we're going to do is, I want to know, we're going to do this quickly. We're not going to spend a lot of time on this. All right? We're going to do it quickly. Clear? First, let's do, you see I have this dotted line for the listening audience, the viewing audience? That's because I give equal credit to the label as I do to the number. How many people have ever, in past years, you just put the number, who cares what it's called, right? The number's all important. Raise your hand if you feel that's true. Yeah, everybody's raising their hand, right? I give equal credit to the label and the number. Okay, you don't put the label, you lose just as much credit. Okay? So, these are called, I call these seasoned chemistry teachers who have developed bad habits may not want to watch this video. Because you probably use factor label method, and I don't like that. Because it doesn't demonstrate what's going on here relative to classic chemistry and the concept of ratios and proportions. Okay? So what I like to do is I like to write stoichiometric masses above the equation, which illustrate the conservation of mass and how the equation reacts relative to the masses that are listed relative to the moles. This says 3 moles plus 1 mole is 2 moles, correct? So 3 moles of hydrogen would have what mass? 6, right? 6 grams. This would be 28 grams. This will be what? 34 grams, and you can see that 6 plus 28 is 34. In terms of volume, remember, if you have a reaction, and it's at STP, and all our reactions are considered at STP unless otherwise noted. When we do gas laws, we'll do reactions at temperatures other than STP, yes? But right now we're just using, everything's at STP, right? What is going to be the volume of hydrogen if nitrogen is 25 liters? What is the volume of hydrogen going to be? Yes?
It's going to be 75.
It's going to be 75? Is that right? Anybody else? Yes?
I think I got 5.
5?
I don't remember.
You don't remember. That's okay. All right. That's Simon. He sometimes short-term memory thing. That's okay. It's all right. We like that. That's fine. All right. Well, this is 1 mole of that. And what's the rule? I have 1 mole of nitrogen over 3 moles of hydrogen. And that's 25 liters. What's X? What's X going to be? 75. So, is she right? Correct. So this will be 75 liters. Can you see that? 75 liters. Can you see that? And what would this be? 50 liters. Okay, now, let's do the masses. How are we going to do that? How are we going to do the masses? Oh, I didn't finish this up here, did I? I didn't, did I? I was so excited about that chemical reaction. You know what? I'm not going to finish it until I show you how this is settling. So you know what? I'm not going to finish it yet. All right? I know Jen's thinking I made that mistake. Well, I could say that I wanted to show you the precipitate before I balanced it. Right? Okay? So let's continue with this. So I know that, let's do this one. I know that I have 75 liters, right? Yes? But do I have 3 moles of hydrogen? Do I? Do I have 3 moles of hydrogen? No. If I had 3 moles of hydrogen, what volume would I have? If I had 3 moles of hydrogen, what volume would I have?
67 liters.
Go ahead.
67 liters.
67-ish? 22.4 times 3, right?
67.2.
67.2. I like that. He's so exact. Right? Is that like a Danish thing? Input? Simon's going, no, absolutely not. I like that. Flexibility, though. You know, that shows flexibility. You know, one guy's very precise. The other guy's like not so precise. I like that. Are Danes flexible?
Yes,
Very flexible. Man's very flexible. Excellent. But Danish was not created by a Dane. We had that discussion. I like that discussion. It was actually created by an Austrian. I like that. During a baker strike. Go figure, right? Okay, now. So, so I have 75 liters. So how much hydrogen do I actually have? How many moles of hydrogen do I actually have? Well, if I had 1 mole, I would have 22.4, right? Right? But I have 75 liters. So what is 75 divided by 22.4? Kamal and Mohammed? They're having a rough day today. Mohammed wants to like rip my face off today. Look at him. Look at his look at Mohammed. Everyone look at Mohammed. That is a sign of really being, you know, sleep deprived. He's got to get more sleep. Yes, Jen.
3.34.
What is it?
3.35.
3.35. Excellent. So X would be 3.35 moles, right? We don't use an S on that. Moles, right? 3.35 moles, right? What's the mass of 3.35 moles of hydrogen? Well, may I erase this? My little workspace here. So what is the mass of 3.35 moles of hydrogen? Well, 1 mole of hydrogen has what mass? 2. 3.35 moles times X. What's that? I know you can use factor label, and I call it brain dead, but no one's learning any chemistry that way. It's not going to happen. Yeah, I know. But I'm talking about the average student. Yes? 6.7? Excellent. 6.7, and that is correct. 6.7 grams. All right? what do you get now? We can do mass, right? So 6, we could do 6 is to 6.7 is 28 is to what? We could do that. Or we could, and I'm just going to write this one out, and then we're going to do the last one using conservation of mass, right? So 6 is to 28 as 6.7 is to x. What's x going to be? A little bit more than 24, right? What is it? 28 times 6.7 divided by 6. What do you got?
31.
What is it?
31.2.
31.2. Is that what you got? Yes? And what is 6.7 plus 31.2? Ran out of room. Grams, right? Okay? Yes? Yes? Okay. We'll do the scoring in a minute when I finish the film. But let's finish this. How do I balance this? How do I balance it? Yes.
2 NaI.
Good. Excellent. Now, let's see if we can see this. Can you see this starting to fall out? It's hard to see from there. Let's see if you can see it on the screen here. Okay, can you see that? Can you see it falling out? It's hard to see it. But if I come, I'll put this up on the side, and I'll do, this is kind of like a test review. I'm going to actually call this test review 3. It's hard to see it falling out from there, okay, but it is actually falling out. If you come up here and look at it, you can see that the top is starting to clear, and I'll put it in the back, and I'll bring it out. What's today? Oh, we don't have class on Thursday, right?
No.
I'll just leave it there till next week, okay? It'll be safe. Clear? Okay? All right. So we're done. So this is going to be test review 3, okay? Yes? All right, are we cool? Excellent. So we had equation writing, nomenclature. We had moles, mass, volume, stoichiometry. Yes? Okay, are we off? We're off.